All right, we're talking today about trig ratios. That's the abbreviation for trigonometric ratios. Remember that a ratio is simply a fraction. That's all you're dealing with. If we have a right triangle, doesn't matter what it really looks like, we can talk about these relationships between the sides and the angles. And there have been three of them really developed, three main ones, and then a few others get added later. But we talk about the sine of an angle, and we abbreviate that with SIN. Now the actual word is spelled SINE, but when we abbreviate it, and especially on calculators and everything, you see SIN. Try to refrain from calling it sin at parties, because people will look at you like you're weird, So the sine of angle A is a relationship between two of the sides of this triangle. Now, if we're starting at angle A, this side across from it would be considered the opposite side, and this side that's right next to it would be considered the adjacent side. This side of a triangle is always the hypotenuse, whether we're dealing with side A or angle B. But for our discussion right now, I'm going to talk about angle A. We could do everything from angle B, then this side would be the opposite, and this side would be the adjacent. But the hypotenuse is always going to stay opposite of angle C, the right angle. So this particular ratio of the two sides would be sine is the opposite side divided by the hypotenuse. And I'll abbreviate those just for your notes. And so we use the three letters to kind of help us abbreviate that relationship. Sine is opposite over hypotenuse. Well, there's another one that says cosine. That's how it's spelled. And we abbreviate that with COS, the cosine of angle A, and that is the adjacent side divided by the hypotenuse. And so, of course, that's how we're going to abbreviate that, CAH. Cosine is adjacent over hypotenuse. And the last of the three trig ratios, or the three main trig ratios, is the opposite divided by the adjacent. Okay, so you can see that we're going to abbreviate that. Tangent is opposite over adjacent. And so when I refer to SOH-CAH-TOA, what I'm referring to is an abbreviation which helps me remember the trig functions, so that I can understand the relationships between the sides and the angles. Now we're going to use these to find sides, and we're going to also use them to find angles. So for instance, I'm going to run and grab my calculator because I forgot to grab it when I was back at my desk. So this is when the music is supposed to play, and it's wonderful, and you're happy, and you go get a restroom break, and then you come back, and we can do the math now that I have my machine. All right, so CAH-TOA. Bad joke, sorry. Let's suppose I'm dealing with a 20-degree angle right there in that particular corner of this triangle. Remember, just like in geometry, they always would get away with murder by not drawn to scale. All right, that way they can draw anything they want, however they want to, and nobody can complain. Well, we're going to have a side length that we don't know and a side length that we do know. And the goal is to find or solve for x. So you have to think about which of the three trig functions you're dealing with. Is this sine? Is this cosine? Is this tangent? Well, based on the angle, I see that I am looking for the opposite side, but I have the hypotenuse. So which one of these uses opposite and hypotenuse? Well, it's obviously this one. So we can say the sine of 20 degrees equals x, the opposite, divided by the hypotenuse. Now we know all of us know that anything can be divided by 1. Well, what does that look like? That sure looks like a proportion. That's right. So how do we solve proportions? We cross multiply. So 1 times x, that's not too difficult. And 5 times sine 20 will be on the other side. Now you want to make sure that your calculator has these letters D, E, G for degree on it. If it doesn't, if it has something else, there's a button right here that says DRG, and you want to press that button, and you want to make sure that you choose DEG by hitting the enter button, and that will make sure that you have DEG in the corner there. That's very important when we're doing these problems, that we stay in the degree mode. There are 2 other units of measurement which we're not going to talk about right now because they will only confuse you, maybe on down the road second semester if we get a chance. But definitely you'll talk about them next year, and one of them mainly. So all I need to do is 5 sine 20. My calculator tells me that the length of side x is 1.71, and it's approximate, so I'm going to leave it at its approximate value. So each time I'm looking at these situations, I'm trying to understand what type of right triangle am I dealing with. If I have a 62-degree angle and I'm looking for this side, and I know this side is 9, which of the 3 trig functions am I dealing with? Well, I'm looking for the adjacent side. I have the hypotenuse. Which one of those is adjacent hypotenuse? Well, yes, that's cosine, right? So cosine 62 degrees equals x over 9, and adjacent over hypotenuse, and we're going to cross multiply to find the answer, right? So 9 cosine 62, right? 9 cosine 62 gives me 4.23. So squiggly lines, 4.23. Well, how is that different from a question like this? So 62 degrees, we have this and we have this. Well, it's not a whole lot different. You still have the adjacent side, but this time you're looking for the hypotenuse. So we're still using cosine. It's just that we have the adjacent and we're looking for the hypotenuse. Now, it's still a proportion. We still are going to cross multiply. So x times cosine 62 is equal to 9 times 1, but this time we have to divide by cosine 62. So to get this answer, we're going to take 9 and divide by cosine 62, and that's going to give us 19.17. So x is approximately 19.17. We can also use these trig functions to find angles. Suppose I have a right triangle and I'm trying to find an angle. We'll call this angle side A, or angle A I should say. And we have a 5 and we have a 6. Well, we have the opposite side and the adjacent side. Well, which one of those it uses opposite and adjacent? That would be the tangent, right? So the tangent of angle A is opposite over adjacent. Now this one does not require that I'm going to cross multiply anything. We are trying to find angle A. So we need to get rid of tangent. Here's the cool part. If you look at your calculator and you have the buttons that say sine, cosine, and tangent, right above them they say sine inverse, cosine inverse, tangent inverse. Those inverse functions with the little -1 there are the ones that will find the angles. So of course we're going to be using tangent inverse for this problem because we're dealing with tangent. So angle A is going to be tangent inverse of 5 over 6. What we really did was we took the tangent inverse of this side And we did the same thing also to the other side. We did it to both sides, and in so doing, we can see that these would cancel out on this side and leave me with tangent inverse 5 6 on the other side. So I'm going to use my calculator. This time I'm using that second, the blue button in the upper corner. No, you can't tell it's blue, but you know, those of you playing at home might have the same type of calculator. So use that second button, and then you have 5 divided by 6, and then you can tell me that the angle of measurement is 39.8 degrees. 39.8 degrees, approximately, right? 39.8 degrees. So we can use the inverse functions to find angles. And it doesn't matter whether we're talking about if we've decided that it's sine that we're dealing with, you know. So we're trying to find angle A, and we have 6, and we have 10. We have opposite and hypotenuse. Opposite hypotenuse is sine, so that would be sine of angle A equals 6 over 10. Well, okay, in that case, then A is equal to sine inverse of 6 over 10. And we can figure out our approximate value by just typing that into our calculator, sine inverse 6 over 10. Oops, typed the wrong thing there. And sine inverse 6/10 gives me 36.9 degrees. So approximately 36.9 degrees. Not too terribly challenging to find sides or angles. And that wraps it up for these notes. And we'll do other examples in class.